In our previous videos, we said the process of excretion includes three major steps: filtration, reabsorption, and secretion. Our previous videos have looked at the processes of filtration and reabsorption, so here we want to focus on this process of secretion. As a quick reminder, most small chemicals get filtered out of the blood at the glomerulus, and most of those chemicals are things we want to retain, like water, glucose, amino acids, most of our sodium, and most of our potassium. So we selectively reabsorb most of the filtrate back into the blood. If, however, there are chemicals we don't want to retain, the simplest way is to not reabsorb them, to filter them out and leave them in the nephron tubes. Alternatively, we can also selectively secrete those unwanted chemicals. We can pump them out of the blood and into the nephron tube to be part of the urine. This works for any chemicals we have in excessive amounts, as well as for those chemicals that were too large to get filtered out of the blood at the filtration step. Transporting those chemicals from the peritubular capillaries into the renal tubes will move that chemical from the blood into what will eventually become the urine and push it out of the body. Essentially, this is the reverse of tubular reabsorption, a selective process for removing chemicals from the bloodstream. Secretion is the primary way by which we can dispose of our nitrogenous wastes like ammonia, urea, and uric acid. Ammonia, urea, and uric acid are small enough that they can be filtered out of our blood in glomerular filtration, but some of these, like urea, do wind up getting reabsorbed. So we have to spend a little bit of energy selectively pumping these nitrogenous wastes out of the peritubular capillaries and in to what will eventually become the urine. We also use secretion to help us control the concentration of hydrogen ions and bicarbonate ions that are traveling through the blood. This is the kidney's way of helping us control pH levels in the body, because the hydrogen ions represent acids and bicarbonate ions represent bases. If we can control how much of that we retain and secrete, we can use our kidneys to fine-tune acids and bases and pH within the body. Secretion is also a way that we can get rid of excess potassium ions. This is largely regulated by the hormone aldosterone. We can secrete out creatine, as well as organic acids and bases, and certain drugs and metabolic products that are bound to plasma proteins. Remember, our plasma proteins are too large to filter out of the blood at the glomerulus, so any drugs or metabolic products that are bound to those proteins also wind up being retained in the blood. Here, we can spend some energy to selectively pump those materials out of the plasma and into the urine. The proximal convoluted tubule is the major site where secretion happens. Most things that get secreted, like our hydrogen ions, our ammonium ions, and certain drugs, are secreted here in the proximal convoluted tubule. However, potassium ions can be secreted in the distal convoluted tubule as well as the collecting duct, as long as the hormone aldosterone is present. Aldosterone causes the selective reabsorption of sodium at the distal convoluted tubule, as well as the secretion of potassium. Overall, urine formation happens by this combination of filtration, reabsorption, and secretion. Most of the action is taking place here in the proximal convoluted tubule. Here's where we are reabsorbing most of the chemicals that we want to retain back into our blood, and also where we're secreting things like ammonium and hydrogen ions to become part of the urine. As that filtrate, as that fluid moves its way through the rest of the nephron, we continue to fine-tune just what we pull back into the blood and what we push into the urine. We wind up retaining most of our water. We also wind up retaining most of our sodium. But we can spend some energy to secrete out additional urea, as well as secrete out excess potassium in the presence of aldosterone. So what winds up actually traveling down through the collecting duct and leaving the body as urine is a combination of materials that got filtered out and not reabsorbed, as well as those chemicals that we spent some energy to selectively secrete out of our bloodstream and into the urine.